All right, so before the weekend, we took a look at trig equations, and I tried to deal with the trig equations that have no change in their period. So that was normal period. And then we were also only looking at values between 0 and 360. In reality, there's more to it than that, and so that's why I broke it up into lesson 11.6a and 11.6b. All right, so got to remember, again, the trig functions are periodic. Therefore, again, they have an infinite number of solutions, right? There are an infinite number of solutions. In the linear method, remember, the wave goes forever backwards left into negative land to negative infinity, and forever positive to positive infinity. The radial view, you can spin around an infinite number of times in either direction. So again, we're infinity. So how do you give all solutions? So to indicate all solutions in degrees, you then have to deal with adding 360n. Whoops, I don't want that to be red. 360n to each value. Now put a little asterisk here because this is for a normal period. And again, I'm talking about the sine and cosine, not talking about the tangent, because the tangent period is 180. If you were doing the tangent, it'd be 180n. This is for a normal period. Later on, we're going to deal with different periods, and we're going to have to take that into account. So let's say, for example, the period was 90 degrees. Then the wave repeats every 90 degrees instead of every 360. So we wouldn't say 360n, we would say plus 90n. And all the n is another revolution. So for example, let's just go back to 360n. All right, so we have a value. Let's say the sine is, we'll go easy, 60 degrees. Isn't the next value that 90 plus 360, an n of 1? And that value would be 450. So you hit that exact same value again at 450. Well, what if n was 2? 720. Well, add the 90, and now you're at 810, and you hit that point again. Make n 3, and what are you, 1080? So 1080 plus the 90, 1170, you hit that value again. And you keep hitting every 360, forever forward. So for one revolution, n is 1, 2 revolutions, n is 2, 3 revolutions, n is 3, 4 revolutions, n is 4, 5 revolutions, etc. forever. And n could be negative. Negative 1, now go negative 360. Go left 360, you'll hit that value. And go left 720, and go left 1080, and go left 1440. And so the n is simply the number of revolutions. Something else? All right. So 360n, and again, if we change the period, it's going to be whatever the period is. 90n, 60n, 120n, whatever. All right? If we were dealing with the tangent, because the tangent repeats every 180, it would be 180n. All right, then you got to do the same thing in radians. So again, for normal, 0 to 360. In radians, that's 0 to 2 pi. So then we have to add in plus 2 pi n. On another 2 pi, and another 2 pi, and another 2 pi, and another 2 pi. So if you got an answer, for example, like pi radians, well, the next time around will be pi plus 2 pi, or 3 pi. And the next time around, add another 2 pi, and you're at 5 pi. And the next time around, add another 2 pi, and you're at 7 pi. And you got a lot of pi. All right? So that's the idea, these rotations. And again, you can go forever forward. You can go forever back. All right, so all solutions. Let's go ahead and deal with it. First example, how in the world am I at C? Oh, because I did it that way. All right, so you got 3 sine theta minus sine theta equals 3/4. Pretty simplistic on the math there. So 2 sine theta equals 3/4. And of course, this is algebra 2, so we all know that this is 3/8, right? Because you multiply both sides by a half. So sine theta equals 3/8. So take your calculators out, punch in sine to the -1 of 3/8, and let's figure out our value. Sine to the -1 of 3/8, and 22.0. 22.0 degrees. Now we are looking for all solutions, so I'm going to take my red and I'm going to add to this plus 360n. Because guess what? The sine of 382 degrees is 3/8. And not only that, add another 360 and the sine would be 3/8. And add another 360 and sine, et cetera, et cetera, et cetera, et cetera. Right? And again, you go forever forward with positive ends, 1, 2, 3, 4, etc., or backwards, negative ends, forever and ever. Okay, so where are we at here? We are at 22.0, somewhere about in here, corresponds to 3/8. And don't forget, there's also another value. I'm going to do it in black. And it's right here, right? So what's that value going to be? What's this second value? And we're 22 degrees away from 0 this way. So we're 22 away from 180 that way. So what does that give you? 158.0? That's this value right here, 158.0. Again, you got to look for all values. And again, we can spin around an infinite number of times. So plus 360n. And that's the first problem. Look, if I kept drawing the wave, you know, look, I can do this first part right here very easily. So right here, right, don't we hit that point again there? So that's back to the first one, the 22 degrees plus the 360n. When n is 1, that's that point right there. And then the 158, if we were to come down, right, that would be the 158 plus 360n. You follow? And it's just going to keep doing this forever and ever and ever. Forever that way, and you can go backwards forever that way. Both directions forever and ever and ever. All right, second one. So you got 4 cosine squared alpha equals 1/4. And hopefully you say, oh, that's quadratic. And you say, oh, there's no middle term, so I can take the square root of both sides. So cosine squared alpha equals, what happens when you do 1/4 and move the 4? You get, good, 1/16. Because 1/4 times 1/4 is 1/16. Okay, so we're going to take square root of both sides. Just doing algebra right now, right? And of course, you aren't going to forget the plus or minus. So we're doing the cosine now of alpha is going to equal plus or minus 1/4, right? The square root of 1 is 1. The square root of 16 is 4. So you got 2 you got to punch in. So the first time you're going to do 1/4, hit your cosine to the -1 button, and do 1/4. Somebody raise your hand when you get that value. What do you got, Luke? Okay, I agree. 75.5 degrees. Now we'll call your attention to the upper right, and we are asking for all values in radians. But you don't think so well in radians. Okay? You just don't. And this isn't going to be a nice, even, like 3 pi over 7 radians. This is going to be decimal radians. And you don't think that well. So just leave it in degrees for now, and we'll worry about radians later. I think that's best for you guys. Just leave it in degrees. Figure everything out in degrees and then convert it later into radians. I think you're safer. Okay, so let's try to figure out where we are, because we got the 75.5. What else? What other value is going to correspond? So I don't know. 75.5 is maybe about there. I'll do blue here. So I'm probably about there. I should probably be a little bit further down. 1/4 is probably a little bit further. No big deal though. If you got it there, not a big deal. Just leave it there. Somewhere maybe about here. But again, we know that we're 75.5 degrees, right? So can you come up with the second value? Right? Can you come up with the second value that goes with this one? And I hope you can. You're just coming across. Now you got to be careful. You are 75.5 away from 0. So this value right here is 75.5 away from 360. And hopefully you think this second value is, did I even do it in degrees? I sure must have. 284.5, right? So leave some space here. I'm going to go 284.5. Okay, but the thing is, we don't want any of these in degrees. We want them in radians, so let's convert them to radians. Everybody remember how to convert to radians? Okay, so that's all we're going to do, right? Got to multiply times pi over 180. But get them in degrees first, and then deal with pi over 180. And look, you're not going to reduce this because you already have decimals. So you're just going to multiply this thing out. Usually we still leave pi in there though. So you're just going to do 75.5 divided by 180. How many decimal places do you go? It's debatable. I went 3. 0.419 pi radians, right? And how do you say all values? What are you going to add to this one? Right, 2 pi n. Don't forget the n. All right, so that's all values for that one. 4.419 pi radians plus 2 pi n. On the second one, what do you get? 1.581. Again, you're dividing 284.5 by 180, and then again, that's pi radians. And then don't forget plus 2 pi n. Be careful, this was quadratic. So again, you got 1.581 pi radians. That R is radians here. I'll put a RAD for you. And then plus 2 pi n. But look, all this came off of the positive 1/4. So go ahead and punch in cosine the -1 of -1/4. And we got to do the same thing all over again. That was all positive 1/4. Punch in -1/4. And what do you get? Somebody give it to me when you got it. Cosine the -1 of -1/4. Who's got it? Somebody raise their hand so I know who I'm talking to. Josh, what do you got? 5, right? 104.5 degrees. Again, I would stay in degrees. You think better in degrees. This is a -1/4. So you're like somewhere about in here, right? And that's a -104.5, right? How are we going to get the other value? Come across. And it's right there. Right? 104.5. Now you got to be careful on this one, because you got a 104.5 degree angle. You can play with the reference angle, but you got to think on this one, because you got to be careful. How can you do it using the 104.5? All right. Would you agree that from here all the way to here is 104.5 degrees. Agreed? Would you agree from here all the way to here, therefore, will be 104.5 degrees because it's symmetrical. So that's the way you can do that one. So somebody punch in 360 minus 104.5. And what's it? 255.5? Okay. So the second angle is 255.5 degrees. How are you going to finish this up? Convert it all to radians. So I'm not going to take the time right now to finish this one. But it's the exact same thing of what we've done earlier. And by the way, don't forget the 2 pi n. I'm just going to leave it this way. You would finish it and get numbers if we had the time. It's exactly the same two answers like we got the first time. And again, you're going to finish that thing off. If you're really curious, it's 1.58 pi. Oh, it's 0.580 pi and 2 pi radians and 1.419. But same concept. So again, we got to take what we learned and we got to apply it to this situation. So what's the difference from what we did last assignment? Now we're adding all possible values. And I did throw in 1 radian problem with you. And how would I do radians? I would find the degrees first and then convert it to radians. Way easier. If you look, your calculator will give you the cosine of 1/4 in radians if you want it. But then you got to figure out what the other value is in radians. And good luck with that. Some of you can do it. You understand fractions and you understand the way it goes. You could do it. Most of you, it's easier going degrees. All right. Number 2. Number 2, solving trig equations with a different period. So the b value is no longer 1. We have a different period. And you can see by the first example, we have a 2 there. Oh, by the way, you might want to cross out your graph, this one right here, because somehow this one got there instead of the one that should be there. So anyhow, you'll see that in a minute. All right, what's the period of this wave? All right, so let's pause. Do you remember how to do periods? Do you remember how to figure out periods? We're dealing with the sine. What's the normal sine period? How many degrees? Normal sine, 360. So how do you come up with the period of this wave? Take the 360 and you divide it by 2, right? And therefore we come up with a period of 180 degrees. Again, what does that 2 tell you? You get 2 waves in the space that you normally get 1. 2 waves in the space that you normally get 1. 2 for 1 deal. Right? Okay, so the linear should really look like that, not the way you guys have it, because again, there's 2 waves, right? You agree? Look, 0 to 180, there's 1 wave, there's the period. Again, the wave repeats. You get 2 waves in the course of a normal 360. All right, how do you solve these? Well, we are going to isolate the trig function. So you got to move the 5. That's pretty easy. We know how to do that. We're going to divide the other side by 5. Because it's multiplied times the trig function. Nothing different. We've done that, right? All right, here's the thing. How do you take care of that 2? You don't yet. You don't. You don't. You don't. At this point, I'm at sine 2n equals 3/5. And I would write this step in because this is what you have to remember. So the measure of angle 2n is sine to the -1 of 3/5. Sine to the -1 of 3/5. And you're punching that into your calculator. You're doing sine to the -1 of 3/5 right now. Okay, I'm going to get rid of the measure of angle just for your sake. So we have 2n equals, and did you get 36.9 degrees? Okay. Okay, so 2n equals 36.9. If this would have been a normal period, it would be 36.9. But guess what? It's not normal. Our period's 180 degrees, not 360. We get 2 waves out of every 360, not 1. And therefore, if we're going to figure out the value, now mathematically, we move that 2. And now you divide the 36.9 by 2. So here, angle N ends up being 18.4 degrees. This is what I would advise. And this is how I do these problems. You guys understand that the more you round off, the farther you get from the true value, right? The further away you keep getting from the actual value. So, when I wrote 36.9, that was a round off, yes? I may have written that down, but I left that value in my calculator, and then I divided the value I had in my calculator by 2, and therefore the final round off was 18.4, not 18.5. If you divide 36.9 by 2, your round off is going to be 18.5. If you divide sine to the negative 1 of 3/5 by 2, your round off is going to be 18.4. It's a tenth, but it is more accurate. Okay, so what did we do so far? We didn't mess with the 2 until we got the angle, and then we divided the angle by the b value, the 2. Therefore, what we really actually have is an 18.4 degree angle. If I could show it to you on this sketch, again, you guys can't do this in your notes because I had the wrong graph, but just look up, just look right here. So if the period was normal, we'd have had a 36 point something degree angle. Something about right there, 36.9. But guess what? The period is different, and so instead, same horizontal value, we're moved over, and we're right there at 18.4. That's what's going on. Okay, how do you figure these out? In my estimation, the easiest way is the radial view here. The radial view does have some things that you have to apply that we've learned, like reference angles, and when the functions are positive and negative. You have to apply both of those in the radial view. Let's see if we can do that. How do I start off? First off, I start off with a period. Instead of all the way around being 360, all the way around is 180. So halfway around is how many degrees? I'm putting in 90 right here. Halfway around. I'm putting a 90 right there. And therefore, up here, I'm going to put a what? Again, if you go to sleep right now, lots of luck to you. All right, 45 degrees goes there. So we got 45, 90. So what's down here? 135, and that makes 180 all the way around. I set up my radial view for my period. If I do this, I can figure everything else out. Okay, I'm going to take my red, and let's do an 18.4. But just remember, all the way up to here is 45. And again, we're just guesstimating. 22.5 would be the middle. So I'm about like that, right? This is 18.5. Something about like that. So remember, we got to find all values. Okay. So 18.4, sorry. Come on, Kool-Aid drinkers. Are you thinking out there? Are you thinking? Okay. Is the sign positive or negative right now? What was the 3/5? Was it positive or negative? Positive. Sign is positive. What other quadrant is the sign positive? Quad 2, 3, or 4. It's positive in one other quadrant. Okay, do you remember what the sign is? The sign is the opposite over the hypotenuse. Where else is the opposite side positive? In quad 2, right? Keeping the opposite side positive. Quad 2. All right, and so now the reference angle is 18.4. Do you now know how to come up with this second value? Now again, some of you struggle with this, and I don't know why. If all the way in here is 90, I have to back up how many degrees? So how do you get that value? 90 minus 18.4. Exactly. So what is 90 minus 18.4? So 90 minus 18.4 is 71.6. .6 degrees. Okay. Now here's the thing. We found the two values within that one period. So we found this one and we found this one, right? 18.4 less than 90. How do we get to this one? Well, you take your first and you add the period. Add 180 to your first. And you'll get the next one, which is 198.4. And how do you get the last one? You add 180, the period, to your 71. So what is that? 251. 251.6 degrees. That's ugly. 251.6 degrees. Tricky? Yep. Doable? Yep. All right, so here's your values. 18.4, 71.6, 198.4, 251.6. Now, if they would have said all values, so don't lose me on this. Listen now, watch. If they'd have said all values, I'd have said 18.4 plus 180n. That would be all values. And I'd have said 71.6 plus 180n. That would have been all values. All right, let's see if we can get a couple more in here. We'll do the math a little quick. Move the 1, do you agree? Get a 4. Move the 7, do you agree? Get a 4/7. And before I go any further, I better take a look at what the period will be. So on this one, everybody thinking, what is the period? So I'm going to ask you on 3. Here we go, 1, 2, 3. 120, right? Again, 360 divided by 3. Period is always, for sine or cosine, 360 divided by the b value. Okay. So I have sine 3a equals 4/7. So remember, at this point, 3a is going to be sine to the negative 1 of 4/7. Punch that in, see what you get. Hope you're punching, because you need practice. 34.8. 34.8. Sine to the negative 1 of 4/7. 34.8 degrees. That would be for a normal period. Do we have a normal period? Nope. So what do we got to do? Divide it by 3. So again, I leave what's in my calculator, though I wrote 34.8. I still have what's in my calculator. And the measure of angle A is 11.6. 11.6. Okay. Let's deal with this one first, and then we'll deal with the second, all the second possibilities. So let's just deal here. Again, what am I going to do to my radial view? I'm going to cut it up into a 120 period. All the way around is 120. Halfway around is 60. Half of the half is 30. Half past the half is 90. And I'm going to cut it up. If you want to go all the way around and put the 120, feel free, right? Because, again, this is what we have to deal with because we're at 11.6 and it's periodic and it's going to repeat every 120 degrees. So now I'm just going to stick in 11.6. All right. Again, I'm here. Another positive sign. So before I go any farther, let's get the rest of the values for 11.6. All right, so use green here. So I have an answer at 11.6. I also have another one. Do you agree 120 degrees more? So that's at what? 131.6. There's a second value. Is that all I have? No, I got another one at another 120 degrees. And that's a 251.6. Do I have another one, 120 more? No, because I'm outside the 360, right? I said give it 0 to 360. Next one gets me at 370, so too far out. So those are all the values there. Again, how do you find the other values for the sign? Sign is positive here. Sign is positive here. Again, you're looking at the opposite. And I need to get to that last problem, so let's speed up a little. So hopefully you agree, 11.6 reference angle, right? So how would you get this value? Back up from how much? 60, how many? 11.6. So what's 60 minus 11.6? And what do you get? 48.4? Right? That's that one right there. And again, you got to do the 120 thing. So that's our first value that way. Plus 120 gives you 168.4. That's our second value that way. Plus 120 gives you 288.4, and that's our third. And again, you can play around with the linear view. You'll see that they pop up that many times. Let me get to this cosine because I want to deal with the cosine and how to do the radial view. So I got to go real fast here. Move the 3, you get a -2. Move the 7, you get -2/7. Agreed? So cosine 4b is -2/7. So hit your cosine in -1. Don't worry about doing it. You get 106.6. So when you do cosine the -1 of -2/7, you get 106.6. Divide that by what? 4. And now what do we got? Measure of angle B is 26.7 degrees. 26.7 degrees. Okay, so again, 4b equals 106.6 divided by 4, 26.7. So period on this one, 360 divided by 4, this thing has a period of 90 degrees. And again, you got to keep track of the periods on these. So halfway around is going to be 45. Half of that's going to be 22.5. You say, yuck. Oh, well, it's the way it is. Add 22.5 to 45, and you get, what, 67.5, and all the way around is 90. Is that okay? Again, I'm just using my period, right? Because, again, I got to figure out these values. All right, I'm going to take my red. All right, so right now I got to deal with a 26.7. Now look where you're at. That's 22.5, so we got to go past that. So I'm just going to stick it like right there. Make it big enough to where I can write in. So this is 26 point. Oops, take that back. This is 26.7 degrees, right? So that's our value, 26.7. What is the cosine in quad 2? It's negative. It's got to be negative. Look, we did cosine 4b equals negative 2/7. Where else is the cosine negative? Quad 3. Where else is the sine? So the sine is positive in 1 and 2, negative in 3 and 4. Cosine is positive in 1 and 4, negative in 2 and 3. Okay. Before I go too far, I better do all these values. Boy, if we have time. All right, so I'm not going to... Good, this said find all values in degrees. So 26.7 plus how many n? 90 n, right? Because it's a 90 period. And let's figure out this last angle. Most will like to figure out the reference angle right here and then add that same amount to 45. There's another way to do it, but most will do it that way. So this is 71.7 plus 90n. 71.7 degrees plus 90n. All right, I got to give you a worksheet. You definitely don't want to do these in the book, and hopefully you'll have some fun. Hey, review tomorrow. Test on Wednesday. Isn't that cool? Awesome. Ready for the weekend. Ready. Hopefully a few Alex. Sorry. Got 2 there. Yeah, take it back. That's possible. 63.3.
Assuming 1 is past 67.
Oh, it can't be. Yeah, it can't be. 63.3. Yeah, it can't be 71 point. Yeah, no way. Yeah, it's actually 67.5 minus 26.7 would be an easier way to do it. If you want to stick with this. Yeah, it sounded like who knows what I did. But you're right, I agree.